In December 2025, something extraordinary passed quietly through our solar system. Interstellar comet 3I/Atlas, born around another star, became the focus of a global scientific campaign. But this time, scientists didn't just watch it glow in sunlight. They studied it in X-ray light, revealing hidden chemistry and offering rare clues about worlds beyond our own. When astronomers observe comets, they usually rely on visible light or infrared signals to study dust and familiar gases. With 3I/Atlas, however, scientists added a powerful new tool, X-ray vision. The European Space Agency's XMM-Newton Space Observatory observed the comet for nearly 20 hours in early December, capturing something rarely seen so clearly in an interstellar visitor. The X-rays detected from 3I/Atlas were not unexpected, but they were incredibly valuable. As the comet releases gas while traveling through the solar system, those molecules interact with the solar wind. This interaction naturally produces low-energy X-rays, creating a faint but measurable glow. XMM, Newton's highly sensitive EPIC-PN camera allowed scientists to map this glow in detail. What makes X-rays so important is what they can reveal that other telescopes cannot. While optical and ultraviolet instruments are excellent at detecting dust, water vapor, and carbon-based molecules, they struggle to identify gases like molecular hydrogen and nitrogen. These substances are nearly invisible at most wavelengths, yet they play a major role in understanding how icy objects form. X-ray observations are uniquely sensitive to these hidden gases. That means XMM-Newton isn't just confirming that 3I/Atlas is active, it's helping scientists determine what kind of materials it carries. In effect, X-rays turn the comet into a natural laboratory, allowing researchers to study its chemistry without touching it. For an object that originated beyond our solar system, this is a major breakthrough. Instead of guessing based on surface brightness alone, scientists can now analyze gases that may reflect the conditions of another planetary system. This approach transforms 3I/Atlas from a fleeting curiosity into a serious scientific opportunity. The excitement around 3I/Atlas goes far beyond this single comet. It connects directly to long-standing questions raised by the first known interstellar visitor, 1I Oumuamua, discovered in 2017. That object displayed unusual behavior that sparked debate about its composition, particularly whether it contained rare types of ice. Some researchers suggested that Oumuamua might have been rich in hydrogen or nitrogen ice, materials that would explain its motion without producing obvious dust. The challenge was timing. By the time scientists proposed these ideas, Oumuamua was already far beyond reach, leaving those hypotheses untested. 3I/Atlas changes that situation entirely. Unlike its predecessor, this comet is actively releasing gas while still close enough for detailed study. XMM-Newton's X-ray observations are especially valuable here because they are sensitive to exactly the types of gases linked to those earlier theories. By combining X-ray data with infrared measurements from telescopes like James Webb and Sphere-X, scientists can compare the presence of water, carbon compounds, hydrogen, and nitrogen in a single object. This multi-layered view allows researchers to test whether interstellar comets share characteristics with objects from our own solar system or represent a fundamentally different population. Another key question is how common these materials might be across the galaxy. If 3I/Atlas shows a chemical makeup unlike typical solar system comets, it could suggest that planet-forming environments vary widely between stars. On the other hand, similarities would hint that many planetary systems evolve in comparable ways. In either case, 3I/Atlas serves as a bridge between theory and observation. It offers a rare chance to move beyond speculation and gather real data about matter formed far from the Sun. That makes every photon detected from this comet scientifically meaningful. The scientific value of 3I/Atlas is amplified by timing. In December 2025, the comet made its closest approach to Earth, passing at a distance of roughly 270 million kilometers. While that may sound vast, it is close enough for precise observations across multiple platforms. This brief window allowed space-based observatories and ground-based telescopes to work together. NASA provided imagery and tracking data. ESA delivered X-ray measurements, and astronomers worldwide coordinated observations to capture the comet's behavior from different perspectives. Such alignment is rare and cannot be repeated once the comet exits the solar system. Because 3i Atlas is too faint for unaided viewing, much of the public engagement came through live telescope streams and visualizations. These efforts helped bring a complex scientific event to a wider audience, while researchers focused on extracting as much data as possible before the opportunity passed. Timing also matters because comets change as they travel. Their activity levels, gas output, and brightness evolve with distance from the Sun. Observing 3i Atlas near its closest approach allowed scientists to measure these factors under optimal conditions, improving the reliability of their conclusions. Once the comet continues on its path, it will fade from view and move back into interstellar space. No spacecraft is currently positioned to follow it indefinitely. That makes the December 2025 observations a complete and final dataset for this object. In that sense, 3i Atlas represents a snapshot, a brief encounter with material shaped by another star. The success of this campaign also sets a precedent. Future interstellar visitors may be studied even more comprehensively, building on what was learned during this carefully timed flyby. Interstellar Comet 3i Atlas offered scientists a rare chance to study material from another star system using tools never applied before. By observing its X-ray glow, researchers uncovered hidden chemistry and tested ideas once raised by earlier visitors. As the comet moves on, it leaves behind something lasting: new insight into how planetary systems form across the galaxy and how much we still have to discover. If you enjoyed this video, don't forget to like, share, and subscribe for more updates on space exploration and scientific discoveries. And don't forget to leave a comment below. Thank you for watching, and see you next time.